So what we can do here, we can do one more thing, like cout number equal to, suppose we are printing some number equal to 10. Okay, we are printing this number, end of line. Okay, if we run this program, then what will happen? First, inside main function will be printed, then we will go to process number function here, and this is calling this function, process number function. So this process number function will be called. So inside process number function will be printed, then this line of statement will be printed, number equal to 10. Then line number 7 from the process number function will be printed. So now this process number function is completed. Execution of this function is completed. Then now we will come to line number 13. Nothing is there. Then line number 14, exiting from the main function will be printed. Okay, let's run this program and see the output. See inside initially inside main function, then inside process number function, because here we have called a process number function, then number equal to 10, then exiting from the process number function, here this line, and then execution pointer will come to main program, here line number 13, then line number 14 will be executed exiting from the main function. See, exiting from the main function. Okay, and so what we can do in this function, we can declare a variable also, integer number equal to 10, and we can print this 10 with the help of number variable. So let's run this program and see the output. Okay, number equal to 10 is printed. So what is happening at stake frame? Okay, I'm not writing stake memory or program memory for the main function. I'm directly writing the memory chunk which is occupied by the do process number program. Okay, this is the frame stake memory, which is frame stake memory, which is occupied by the process number function. So at first line, what will happen inside process number function will be printed inside process number. Then we are declaring a variable int number equal to 10. So here this variable will be declared in this memory, in the frame stake memory. Okay, this variable number 10 will not be declared in the program stake memory. Okay, let me write program stake memory also. So this was our program stake memory, stake or program stake memory, and from here we were calling main function. So initially what was happening initially, inside main function was printed, then we were calling process number function. Okay, process number function. Okay, so execution will go to frame stake memory, which is occupied by process number function. So execution of process number will happen frame stake, and frame stake memory is part of stake or program memory only. Okay, frame stake, this memory is part of this whole chunk in the RAM, stake or program stake memory only. Okay, so what is happening inside the process number function? First, inside process number is printed, then we are declaring variable number. We are declaring and initializing this number variable with the 10 value. So this number variable will have some memory into the frame stake memory, because whenever we run a program, then our program will be converted, our C++ program will be converted into the executable file. Okay, and this executable file will be loaded on the RAM, okay, by the loader, and in RAM execution will start, okay, on the runtime. So on runtime, in the RAM, this memory will be created by the main function, because execution of any program will start from the main function only, and from main function we are calling process number function. So this process number function execution will happen at the frame stake memory. Frame stake memory is a chunk of this bigger memory part. Okay, and here we are specifying what are the instructions and what are the execution happening inside the process number function. Okay, so here uh, line number 6 we have declared this variable, and at line number 7 we are printing number 10. Okay, this number 10 will be printed. Okay, then we are saying exiting from the process number function, we will print exit from process number function, exit from process number function. Okay, so whenever we return from this function, we are returning from this function. So memory occupied by this process number function will be freed. Okay, so this memory will be freed when we return from the process number function. Then we will come here at line number 14, because execution of process number function is completed, so we will come at line number 14. So process number function execution is already completed. This frame stick memory will be deleted because execution of process number function is already completed. We don't have any variable called number because variable number was initialized into the stake memory, and that memory is freed. We don't have any memory occupied by the process number function right now at the execution level, because process number function is already executed and that memory is being freed. So we don't have access to the number variable, because this number variable is local to the process number function only. It was declared as a local variable in the process number function, and whatever memory occupied by this process number function is being freed. So we can't access any variable which was created in the process number function. Okay, so that stake memory is freed, right? Then we have returned back to the this main execution, main program. Okay, we have came here into the main function, and then line number 14 will be executed. Then we will return from the main function. Whenever we have returned from the main function, then this stake memory will be freed, because we are returning from this main function also. So main function occupied this stake or program memory, so this will be freed. Okay, so this memory will be freed. Cool.